because that might be, this is a chapter on matrix or matrices plural, which are actually kind of fun. They're definitely not difficult. The notation looks a lot more confusing than it is. And we'll see by the end of this chapter where matrices are used. These are something that are brand new to you. This is the only course, a little bit in finite, which is the other senior math course. They do these as well, but like they don't fall in Algebra 1, Algebra 2. I don't know if I ever did these in high school. I definitely did a whole course on them in college, so it's been a while. I haven't really taught them in high school in a lot of years.
What else would you call fun? Yeah.
I mean comparative to other things. They are not bad. You guys will like them. Okay. So the first thing you have to know about matrices is rows versus columns. Okay? Rows move left to right, so there are 3 rows here. Columns are up and down, and there are 3 columns. This one has 2 rows, 2 columns. This has 1 row, 3 columns, and they're named based on those dimensions. So they're called M by N, so that's like a 4 by 6, 8 by 3. Your first number is your rows, and your second number is your columns. So I'll just make that rows by columns. And that's important because there's only so many dimensions that will even be able to be added or will even be able to be multiplied. Your dimensions are important for that reason. And your last one here is 3 rows and only 1 column, so 3 by 1. Does that make sense? So rows by columns. Adding and subtracting. Here's how easy it is. I'm going to skip all this because this makes it seem more confusing than it is. If we want to add A plus B, we just add corresponding numbers. So when you're adding or subtracting, your dimensions have to be the exact same. Okay? In other words, this A is a 2 rows by 4 columns, so that's a 2 by 4. I can only add and subtract that with other 2 by 4 matrices. They have to be exactly the same. And this one obviously is 2 by 4 as well. So when you're adding, you just take corresponding parts. So if you look up here, the 2 plus the -3 is going to be a -1. And the setup is going to be the same. So my sum is going to be a 2 by 4 matrix also. My next term, 4 plus 4, is going to be an 8. The next term, 8 plus 0, is going to be an 8. The next term, -3 plus 1, is a -2. Then we move down to the next row. 0 plus 6 is 6. 1 plus 8 is 9. 2 plus 2 is 4. 3 plus 0 is 3. So it can only get confusing because it's a little bit tedious if you don't match something up right. If you're not paying attention and you're trying to teach yourself this later tonight, you'll be very confused also. But if you're paying attention and following, that's not that hard, correct? Okay, with subtraction, A minus B, same thing. 2 minus -3 is going to be 5. Just be careful with your double signs. 4 minus 4, 0. 8 minus 0 is 8. -3 minus 1 is -4. That covers the top row. 0 minus 6 is -6. What will the next term be, Carolina? Not plus, we're doing subtraction. Very good. Next term, Faith? Good. Last term, Allie? Good. So 2 by 4 matrices can only be added or subtracted with other 2 by 4 matrices, and the final sum or difference is also a 2 by 4 matrix, plural, singular matrix. Okay. Multiplication, scalars, 2 forms of multiplication. This first one, scalar multiplication, is really simple. Whatever number you're multiplying by, and again, I'm going to jump right down to the first example. If we want to do 4 times A, we're literally just multiplying all those terms by 4. So that's pretty easy. 12, 4, 20, negative 8, 0, 24. B, only a little bit more difficult because it's a fraction, or in other words, you're dividing by 3, right? Are we all familiar with the fact that multiplying by a third is the same as dividing by 3? So if we do a third of C, and this is a nice matrix to have to do that with because all of your numbers are divisible by 3. So what would that matrix look like, starting with the top left? Maggie? Good? Perfect. And the last one is kind of going to be multi-steps here. So we're going to have to triple A, and we're also going to have to double B, and then we're going to have to do the subtraction between the two of them. Now, first of all, is that even possible? What are the dimensions of matrix A, would you say? Would you say? 2 by 3, Brock says. Everybody agree with that? Remember, it's rows by columns. So 2 rows by 3 columns. So when you do scalar multiplication and you just multiply all of those by a certain number, it's still going to be a 2 by 3. And you're going to have to subtract a scalar multiple of B. B is what dimensions? Also a 2 by 3. So will we be able to do the subtraction? Yes, we will. Okay? So first of all, when I triple A, Laura, tell me what that's going to look like. Keep going. What's that? Right. Yep. Perfect. So there's your 3A minus. Mike, tell me what 2B is going to look like. Good? Perfect. And then I have to do the subtraction, corresponding parts. Sarah, take me through that. Good? Good? Yep. Yep. 0 minus 2. Yep. $18 minus negative 6 will be 18 plus. Yep. So again, not overly difficult, but tedious if you like. I'm not really sure how you said the negative 8 that one time. Oh, in that spot up there. Okay. So it's just tedious, really, is it? But does that make sense? Okay. Now, in this next presentation, we have to essentially figure out what y and x are going to be. So when we take this first 2 by 2 matrix and we subtract 3 times this other 2 by 2 matrix, it's supposed to give us this. So what I'm first going to do is I'm going to really simplify, and I'm going to do 2, and I'm going to do the subtraction and the scalar multiplication almost all at once. So it's going to be 2 minus 3 times negative 1, which is going to be what? 2 minus 3 times negative 1. Nope. Okay, we can't do this all at once. Never mind.
Is there any chance we could just multiply
Yes.
3 by everything?
Sure. Let's just multiply the 3 by everything then. That's what we're here to iron out. How much can we do in our head? How much should we write? Now, I'm not distributing the minus. I'm just distributing the 3. Are we clear with that? So negative 1 is going to become negative 3. Y is going to become 3y. The 3 is going to become a 9, and the negative 3 is going to become a negative 9. If I did want to multiply through the negative 3, I would just need to insert a plus sign between the two matrices, yes? So now, what is 2 minus negative 3? 5. And you know what? That just checks out more than anything, because that matrix over here already had a 5 in that top left spot. Here's where we're going to have to actually do some solving, because the upper right, 5 minus 3y is supposed to equal what? Right, 5. So we're going to be able to use this to solve for y like it asked. So negative 3y is going to equal 0, and y equals 0. And then in the bottom left corner, similarly, I have x minus 9, which is supposed to equal this x lower left minus the 9 lower left is supposed to equal lower left negative 2. Add 9 to both sides, and x equals 7. So I've really answered their two questions. If I just want to make sure this last spot checks out, negative 1 minus negative 9 is negative 1 plus 9, which is 8. Yep, so that was my upper right-hand corner subtraction. So upper right minus upper right needs to equal upper right. So 5 minus 3y had to equal 5, so I subtracted the 5 from both sides first. So yeah?
Yeah, that's equals 0.
5 minus 5?
No, I mean, well, yeah.
And then dividing by negative 3, yep. Okay? All right. You finished the bottom one? We haven't even gotten to the good stuff, right? This is the easy stuff. So this one, solve for x in the matrix equation, 2x plus a has to equal b. So let me ask you this. If you were solving this equation for x, what would you do first? You would subtract a. So 2x needs to equal a, or b minus a rather. Like, right, if I subtracted a from both sides. Does that make sense? So let's actually do b minus a. That would be, make sure you do this in the right order, negative 6 minus 1 is negative 7. 5 minus negative 5 is 10. 9 minus 0 is 9. And 1 minus 2 is negative 1. So 2 times some matrix. X is a matrix. Can we follow that? It's not really a variable in the traditional sense. So actually, truthfully, this should have been an uppercase X. And then really, in order to solve for this matrix X, you would just divide both sides by 2, right? Or multiply by a half. So X is going to equal half of this one. So, Alyssa, what would that be? Negative 3.5, yes. Yep. Yes. Correct. Make sense? Okay. Multiplication of two matrices is most confusing. Ignore the top. I'm going to explain that in real words because that will be very confusing. First of all, the dimensions have to, and I'll show you in a minute. What dimensions is this one? How many rows? 1. How many columns? 3. This is a 1 by 3. This one, how many rows? 3. And how many columns? 1. These two numbers, the columns of your first matrix has to match the rows of your second matrix in order to be able to be multiplied. Okay? Must match. I think it's easier to show it that way than saying it. The columns of the first has to equal the rows of the second. To me, that's a little bit more confusing. So, and you'll see when I do this why that is. So, I wish we almost didn't start with this one. This one's almost too easy. Let's start with this one down here. I'm going to come back to this one. I'll show you why it's too easy, because it's not really going to give you the whole picture, and I don't want you to be confused by that. So this is a more traditional kind. This is a, what's the dimensions? 2 by 3, and this one is a 3 by 2. So are we good? Yes, we are. Right? Okay. So here's how this works, and this is a little bit more thinking in your head to keep track of, because we're going to start in the upper left-hand corner of both matrices. But we're going to take the product and we're going to move across on the first one and down, which is why your number of columns, as we move across on A, has to equal the number of rows on your second one. So what you have to do in your head is, what's 2 times 1? 2. And then you're going to move across this row and down this column. What's 1 times 2? 2. And one more time, 3 times 3. And you have to add all those together, which might be tough to keep track of, so you might want to write that down. And that's going to be one number in your final answer. So 2 times 1 is 2, plus 1 times 2, you guys said was 2, and 3 times 3 was 9. So that's going to all add up to 13, and that's your top left number. Then we're going to go across that row, that same row again with the next column. And then the same row again with the next column if there was one, and so on until you finish. So 2 times 0 is 0. 2 times 1 is, or I'm sorry, 1 times 1 is 1, and 3 times 2 is 6. So that number is 7, and that goes in the next spot. And then we've expired this top row with all the columns over here. And once you've expired the row, you move on to the next row with the first column, and that next row with all the columns thereafter until you finish. So, and when we move down rows, by the way, we're going to move down a row over in our answer. So, what's 1 times 1? Negative 1 times 2. And 0 times 3. So that all adds up to negative 1. So we've expired that row with the first column. Now we got to go through that row with the next column. 1 times 0 is negative 1 times 1. And 0 times 2. So that's all just negative 1. And there's your answer for A times B. Now, with regular numbers, what do you know about A times B and B times A? It doesn't matter. In matrices, it totally matters. Okay? So, here's the thing. When I go to do B times A, I'm going to be honest with you, I like to see the B on the left because I like to keep going across rows and down columns, like across rows and down columns. So I'm going to rewrite these matrices with B truly on the left. Just kind of more for like your rote memorization purposes. You're just used to that like structure. So I'm going to put the B on the left times the A. And not only that, sometimes both directions of multiplication aren't even doable because of our dimensions. So remember, this first one was a 3 by 2, and this one was a 2 by 3. Luckily, that is still doable. Does that make sense? Okay. And so now I'm going to start the B times A process. So remember, I'm going across the left rows and down the right columns. Does this make sense? So I'll keep track over here. What's 1 times 2? 2. And 0 times 1? 0. And so that first number is a 2. I'm going to keep going across that top row and down the next column. What's 1 times 1? And 0 times negative 1? 0. So 1 plus 0 is 1. And I still have to go across that top row one more time. 1 times 3 is 3. And 0 times 0 is 0. So that last number on the top row is 3. Once I've expired that top row, I'm ready to move down to the next row. And in my final answer, I'm moving down to the next row. So 2 times 2 is 4, plus 1 times 1 is 1, so 4 plus 1 is 5. Same row, next column. 2 times 1 is 2, 1 times negative 1 is, so a 2 and a negative 1 adds up to 1. Lots of little stuff going on in your head. Tedious. And then on the next column, 2 times 3 is 6. 1 times 0 is 0, so that's just a 6. And I'm ready to move down to that last row. 3 times 2 is? 2 times 1 is? 6 and 2 makes 8. 3 times 1 is? 2 times negative 1 is? So a 3 and a negative 2 makes 1. Last column. 3 times 3 is 9. 2 times 0 is 0. You have no idea how often that happens. You're like in all these little things and you just want to scratch your head. So there's your answer. Do you notice how, number 1, they're not the same. Number 2, they're not even the same dimension. Right? When you multiply in different orders. What I actually just noticed that I'm not sure I've ever mentally thought before, that's the checking point right there to see if they're even multipliable. That's not a word, but you know what I mean. And I think the answer will be 2 by 2. Versus over here, 2 by 2 was what made it check. And so the answer will actually be 3 by 3, which is kind of cool. You see how those dimensions play out. And you can see now that we've done them, you can see why the number of rows has to match up the number of columns. So back to this one, you guys. The reason I didn't want to start with this one is because it's just across the row, down the column, just one time. The answer is just going to be 1 by 1. What's 3 times 3? 9 plus what's negative 5 times negative 4? And 2 times 5 is 10. So this matrix is just 39. Doesn't even look like a matrix. And that's why I didn't want to do it first, because that now just is confusing. It shouldn't be confusing now. But if I started with that, it would have been a little dishonest for what most of them look like. Does that make sense? All right. Matrix day 1.